This video will review the work from 4.3 through 4.5. When we write these two congruency statements, the order of the letters matter. RS is position 1 and position 2. This corresponds with A and B in the other triangle. In the same way for question 2, angle S is the one in the middle. Angle B is the one in the middle. In question 3, given that these two triangles are congruent, we can match up some of the parts. We can match up FG here with JK, and that would allow us to solve for Y. And we can also match up angle G, the middle angle, with angle K, the middle angle. And finally, we can match up GH with KL. We want to know what Y is, so I think the best fit is going to be FG and JK, and write these out as 12 is equal to 3Y minus 15. This tells us that 27 is 3Y, or that 9 is equal to Y. And that actually is our answer since we plugged that in for KL. Solving for Y, we would write that 4x minus 20 is equal to 108, or 4x is equal to 128, or x is equal to 32. So if we have two polygons, CDEF and KLMN, that are congruent, we just match up the position. F is the fourth angle, N is the fourth angle. KN is the first, then the fourth, so we match that with the first, then the fourth, and then we're looking at CF. In number 7, we're asked to solve for Y. So we know that Y minus 7 is equal to 12, so Y, we just add 7 to both sides and we get 19. Because side AB corresponds with side BC. AB with BC. They're the same segment. The next one, we're looking at congruency statements, and you have to match up the side lengths. So AB matches up with FD. A has the single swoop like F, B has the double swoop like D, and they're connected with the two hash marks like so. I could do more, but that turns out to be enough, as they all have A, B in the first two positions, and only one has FD. The answer is B. In number 9, they tell me that NL is 18. They tell me that SP is 33, so this whole thing is 33. And they tell me that SR, which is this distance here, is 10. They tell me that RQ is 24, and that QP is 30. And they want to know the perimeter of triangle MNR. Since these two triangles are congruent, we can match up sides. So this 30 corresponds over here with 30. Same thing with 33, it matches up over there. And this 24 plus 10 gives us 34, and that matches up at the bottom. So we have 33 plus 30 plus 34. The answer is 97. So triangle ABC is congruent to triangle XYZ, and the first one is 47.1, the third one is 13.8. We want to know what the middle one is. So we can take 180, subtract 47.1, and then subtract 13.8, and whatever's left is our third angle. That turns out to be 119.1. The answer is D. For the proof of this side-side-side congruency relationship, this one is given. Here we know that AB, segment AB, is congruent to segment CD. BD and DB are congruent because of the reflexive property of congruence, which says that a side is equal to itself, right here. And we use the shortcut side-side-side, since all three sides match up. In the next problem, we see in the beginning here that RS and UT are all equal to 61 because x is 18. And then because x is 18, the angles also match up. Then we see that this particular segment, RT, is congruent to TR because of the reflexive property of congruence. In this case, we're looking at the shortcut side angle side. So if we're matching up FG with JK and FH with JL, so FG and then later FH, what's the vertex of those two, FG and FH? It's going to be F. That's the one that shows up in both. So on the other triangle, we're using JK and JL, so we're going to use the letter J. So we have to match up F and J so that it's an included angle. You could draw the diagram and it would make it a little bit easier, but just from the letters you can also solve this. So we know that EG is equal to itself. We know that HG and GF are equal to each other. So then we have to match up these two statements. If I set the two equal and I solve for x, I get that 2x is equal to 11. If I divide that in half, I get x is equal to 5.5. J. So which of these triangles can be proven congruent by one of these two shortcuts? Well, we know all three sides for number 1, so that's possible. And we know side angle side. We see the included angle here for the third one. But the second one, the angle is not included, so that one does not work. So we're looking at 1 and 3, which is choice C. Could you use angle, angle, side? Well, the key here is these parallel marks, and that tells us that QS is a transversal, and then remember that alternate interior angles do correspond. So we have some matching angle relationships here. We also have the right angles in the corners. So do we have two angles in a row, and then QS is equal to itself? So the answer is yes, we could use this shortcut. Could you use the hypotenuse leg congruency shortcut? Well, all we know is that there's two right angles and that VY is equal to itself. We don't know the lengths of the legs or the hypotenuse other than VY. So though it looks congruent, we don't know enough information to know for certain. This next one, since AC is equal to itself and then AD is congruent to BC, yes, we can use the HL congruency shortcut since these are right triangles and the hypotenuse and one of the legs correspond. Could we use the angle side angle congruency shortcut here? Well, we do know that there's some vertical angles here, and we can figure out some matching angles based on these parallel lines and transversals. So I see three angles, but do we know any of the side lengths? And the answer is no, we don't. They tell us here that VS bisects RST and RVT, so that tells us that these angles are equal as well as these angles. And we know that VS is equal to itself, so we have angle side angle, yes. In this one we're trying to use angle side angle, so if we take a closer look, this angle is equal to itself right here. It shows up in both triangles. And to keep these sides included, we need to make sure that we're looking at this angle as we're looking at the triangle here, and this angle as the triangle goes like this. So those angles XVZ and XWY. Choice A. So how can we justify STU is congruent to VUT? It looks like they share this side. Looks like they both have a 90-degree angle, and then we also match up this side. So I would say side angle side. So given this diagram, what is true? Well, we know that there's vertical angles here. Because of the parallel lines, we know that there's some matching alternate interior angles. So no, we don't know for sure that A and B are equal, but we know that A and C are equal. Is CE equal to DE? Not necessarily. If I look at AED, that's red, blue, green. Red, blue, green. If I do that on the other side, I'm looking at CEB. That checks out. C looks good. D has the letters in the wrong order. So in question 9 here, we're given that several of these angles match up. So we want to make sure that these two statements match up. So if 6y minus 2 is equal to 2y plus 7, then 4y minus 2 is equal to 7, 4y is equal to 9, y is equal to 2.25, which is G.